Hello everybody. In this video we're going to be covering one of the sections in chapter 5 of our text, molecules and compounds. In this video I want to talk about how you go from the formula to the name of an ionic compound. So the first thing I want to do is remind you guys of this graphic that we had in chapter 4, where given the position in the periodic table, we can know what the charges are of certain cations and anions that are going to form for a specific element. And I want to remind you guys that we have this large section here and down here where we don't really know because they can form different types of charges. So we have to accommodate for that in our rules. So we know that we're going to be our ionic compounds are going to be made of cations and anions. And we're going to name them by simply naming the ions. Okay, so if it's a cation, it can be of two types. So we can have a type 1 metal. This is one where we know what the charge is. Okay, so it would be in that graphic where it's a metal, it's forming a cation, and we know what that cation is going to form that we're going to know. So we just give it its name. And then we can have a type 2 metal. This is where we're going to need to name the metal, and we're going to have to specify its charge because we don't know what the charge is. It's one of those unknown metals where it could have different kind of charges. And then if our cation is a polyatomic, we're going to name the polyatomic ion. Okay, so an example of this would be like ammonia has a +1 charge. So it would start off as ammonium something or other. If it's an anion, then you can either have a nonmetal. The stem name of the nonmetal name is going to be, so we're going to have the beginning of the nonmetal name, but we're going to change its suffix to "ide." Okay, so you notice like I might not say chlorine, I say chloride. And I don't say sulfur, I say sulfide. Okay. For polyatomic ions, we're just going to name that polyatomic ion. So let's take a look at what happens with monoatomic nonmetal anions and review this a little bit. First, we're going to determine the charge from the position on the periodic table. And then we're going to change the name, changing the ending on the element to "ide." So let's look at some examples here. If we're in group 15, we know that we get a -3 charge, and we rename them. Nitrogen becomes nitride, phosphorus becomes phosphide, oxygen becomes oxide, sulfur becomes sulfide, fluorine becomes fluoride, chlorine becomes chloride. And we have different charges that we're going to associate with them. For metals, we have our type 1 metals, and these are metals whose ions can only have one possible charge. Okay, this includes group 1, group 2, and then a smattering of other metals. And there's actually a few other than just aluminum, gallium, indium that you saw in the graphic before. Like zinc would be one of them. I'm not going to try and catch you up on on any of the assignments or anything like that. But in general, there are a few of them that tend to always be predictable. We're going to determine the charge by position on the periodic table. Again, group 1 is +1, group 2 is +2, aluminum is going to have a 3+ charge, gallium would have a 3+ charge, zinc, for instance, would take on a 2+ charge. And some of these you would just have to memorize, honestly. It would be like zinc 2+, or gold is a +1. Those are just, but I'm not going to really require you guys to do it. But if you wanted to know and be able to identify a type 1 from a type 2, there are a few that just, you gotta know. Type 2 are metals whose ions have more than one possible charge. You're going to have to determine the charge by the context. So we're going to have to use the fact that the overall compound is neutral and that we can predict the charge on the anion to figure out what the charge on the metal is going to be. So let's see if we can determine if the following metals are type 1 or type 2. So lithium is in group 1, so that's a type 1. We know its charge is +1. Copper is going to be a type 2. It's in that center area, and it's typically going to have either a 2+ or a 3+ charge. Gallium is on our graphic. We know that one. It's going to be a type 1, and it's going to take on a 3+ charge. Tin is one of our transition metals again. We're not going to know what the charge is on that. It's usually, again, either a 2 or 3+. Strontium is going to be known, that's in group 2 on the periodic table. It's a type 1, and it's got a 2+ charge. So for the type 1 binary ionic compounds, so this is where we do not have a polyatomic, and we do know the charge. We're going to have, the name is going to be a composite here, so it's going to contain the metal cation plus the metal anion. The metal is going to be listed for first. The metal cation comes first, and then we're going to name the metal anions, non-metal anions second. The cation name is the metal name, and the non-metal anion is going to be named by changing the ending of the non-metal name to "-ide". So our graphic here is the name of the metal plus the base name of the non-metal plus "-ide". So let's try an example of naming a binary ionic with a type 1 metal. I have here capital C, little s, capital F. Let's see if we can break this down. First thing we're going to ask ourselves is is it one of the common exceptions? That's these guys, so no, it's not any one of those. Next, we're going to identify the major class. We know that cesium is a metal because it's on the left-hand side of the periodic table. And we know that fluorine is a nonmetal because it's on the right-hand side of the periodic table. We have a metal bound to a nonmetal, so therefore we have an ionic compound. Then we're going to identify its subclass. Okay, we have 2 elements, no polyatomics, so we have what we call a binary ionic. Then we have to ask ourselves, is this a type 1 metal or type 2? Do we know its charge or not? Cesium is in group 1. We know that the charge on those, so it is a type 1. Next, we need to identify the cation and the anion. So cesium is in group 1. We know that they have a +1 charge. Fluorine is in group 17. We know it has a -1 charge. Then we're going to first name the cation. So the cations don't change their name. We just call them cesium in this case. And then we're going to name the anion. And we're going to remember that we need to change the suffix on this to "-ide". So fluorine becomes fluoride. And then we can write the name with the cation name coming first. So this would be called cesium fluoride. Let's see if you guys can name these following compounds. KCl, potassium chloride. MgBr2 would be magnesium bromide. Al2S3 is aluminum sulfide. Do note that, again, because of some exceptions and historical reasons, we don't write it sulfuride, it's sulfide. Okay, let's go through the rules for naming a type 2 binary ionic compound. So this is where it's not clear to us what the charge immediately is going to be on the metal. So it, again, contains a metal cation and a non-metal anion. The metal is going to be listed first. The name, we're going to name the metal cation first, and we're going to name the non-metal anion second. The metal cation name is the name followed by a Roman numeral in parentheses to indicate its charge. So the caveat here for the type 2 is that we need to indicate the charge on the metal. So we're going to do the metal name, some parentheses, a Roman numeral, that's going to be the charge on the metal, and the parentheses, and then the base name of the anion with an "-ide" on it. We're going to have to determine the charge of the metal based on the anion because we know the overall thing needs to be neutral. There is a table in the book of some of the common type 2 cations and their charges. A nonmetal anion named by change, and we're going to change the name of the anion and give it the "ide." So let's see if we can determine the charge on the variable charge cation in the gold sulfide here. First, we're going to determine the charge on the anion. So what we're going to need to do is we're going to need to go look up sulfur. It's in a group 16. We know that its charge is 2-. We know that from the subscript that there's going to be 3 sulfurs in the formula. That gives us a total negative charge of 6-. So that's 3 times the 2-. We need to determine the total positive charge. We know that to balance the 6 negative charge, the negative 6 charge, we're going to need a positive 6 charge from our gold. And then we're going to divide by the number of cations. So because there are 2 gold atoms in the formula, and we know that the total positive charge is +6, that means that each gold must have a 3+ charge. Let's take a look at writing a formula based on the name of a type 2 metal ionic compound. First, we would write the symbol for the cation and its charge. So this is a little easier for us. So we just look up what the symbol for manganese is, and we know that its charge is going to be 4. Then we're going to write the symbol for an anion and its charge. So we know from its position on the periodic table that sulfide is going to be an S2-. And we are going to play the same game that we did before by crossing those. And we get manganese 2, sulfur 4. But these are reducible in this case. We can divide both of these by 2. So we're going to do that. And it becomes manganese with the 1 subscript implied S2. And we're going to check our total charges. We knew that manganese was in the +4 state. We have 1 of them, so we're going to get a total of +4. And we know that sulfur is in the 2- state. There's 2 of them, so we're going to get a total of -4. So let's see if we can figure out what the formulas are from the following ions. If we have a copper 2 ion with a nitride ion, or if we have an iron 3 ion with a bromide ion. I'll give you guys a second to try that. So if we have copper 2 with nitride 3-, we're going to get Cu3 and 2. And if we have iron 3+ with our bromide ion, we're going to get FeBr3. Again, we're just canceling them out. Okay. So let's do a little practice and see if we can name these type 2 ionic compounds. So we have titanium and chloride. We need to figure out what is the charge on that titanium in order to give it its proper Roman numeral. So we start with the anion. We know that it has a -1 charge. We know there's 4 of them for a total of -4. We know that there's 1 titanium, and it must have a +4 charge in order to balance the -4 charge from the titanium chloride. So therefore, the name of this is going to be titanium, Roman numeral 4, chloride. Do note that there is also a space in between this parenthesis and the anion, but there isn't a space between the metal and the beginning of the parentheses. In this case, we have bromine. We have 2 of them. We know from its position on the periodic table it's a -1. We get -2. There's 1 lead. It must have a +2 charge in order to give us a neutral compound. Therefore, this guy is called lead 2 bromide. Here we have sulfur, and we have 3 of them with the -2 charge. That's a total of -6. We know that iron must have that the 2 irons have an overall charge of +6, but there's 2 of them. That means that each individual one is giving us a 3+ charge. We call this iron 3 sulfide. Okay, we're almost done with the ionics, but we're going to talk now just a little bit about the compounds that contain polyatomic ions. Again, polyatomic ions are single ions that contain more than one atom. We name any ionic compound by naming the cation first and then the anion. So even if we have polyatomics, we're still going to follow this convention. Okay. Here are some of the common polyatomic ions. And we can see that there's at least one of them down here, ammonium, that is a cation, but the majority of them are anions. So typically you're going to see them represented in a formula as an anion. Let's talk about how we're going to write our ionic compounds using the polyatomic ions. Let's see if we can write iron 3 phosphate. Notice that a good way of recognizing that it's a polyatomic in the name is that it ended with 8. So if you see 8 or ite instead of ide, then you're going to recognize that you need to be using the polyatomics. So first we'll write the symbol for the cation and its charge. We have iron, and it's indicated what is its charge, so that one's pretty easy. Iron 3+. We're going to write the symbol for the anion and its charge. So we would have to go to our table, look up what a phosphate is and what its charge is. Phosphate is PO4 3-. We're going to do our swapping of the charges with their subscripts. And we're going to recognize that if we want to write that, what we're saying here is that we're going to have 3 whole phosphate groups. So we need to use our parentheses here. Of course, these are going to cancel. Okay, we already had charge balance here with 3 positives and 3 negatives. So we're going to get our lowest number by dividing these 2 by 3 and not changing anything about the subscripts of the polyatomics, because we do not change them. We treat them as if they are a single atom. We get FePO4. And now we need to check that our charges do indeed cancel out. We get a +3 from the iron, -3 from the PO4, and we have a neutral ion. I'll give you guys the opportunity to try and write out the formulas for an aluminum ion with a sulfate ion and a chromium 2 with a hydrogen carbonate polyatomic. So the aluminum is going to be Al3+, and the sulfate is going to be SO4 2-. And when we combine those together, we get Al2SO4 3, right? So if we think about the charge balance on that, we have aluminum 3+, 2 of them, so that's a +6. We have 3 of the sulfates at 2-, so that's -6, and the 2 balance each other out. If we have chromium, we needed to know its charge. It was told to us it's a 2+, and we have our hydrogen carbonate from the table. We know that that has a -1. We're going to need 2 of these to balance up that 2+ charge, so we get Cr parentheses 2 to indicate that we have 2 of our hydrogen carbonate polyatomics. Okay, now that we have gone from the name to the formula, let's make sure that if we're given a formula for an ionic, whether it be type 1 or type 2, and it does contain a polyatomic, we're not going to be able to let that sway us. We're going to be able to name that guy. So let's try this guy. First thing we're going to do is we're going to ask, is it one of our common exceptions? Nope. Then we're going to identify the major class. We know that there is a metal. So that means that we are definitely in an ionic situation. And then we're going to identify our subclass. We know that we have a polyatomic with our SO4. So we're in the polyatomic ion subclass. Then we have to ask ourselves, is this metal type 1 or type 2? Do we know its charge? We do know the charge on sodium because it's in group 1. Now we can identify the ions. We know that the sodium is going to be Na+, again, because it's in group 1. We know that the SO4 is going to be SO4 2- because we looked it up in our polyatomic table. We're going to name the cation. We know that when we do that, we just call it sodium. Then we're going to name the anion, and we know from our table that SO4 is called sulfate. And then we put them together, and we can write our name of sodium sulfate. We have a situation where we have where we have a metal we do not know its charge, right? We can go through and do the exact same thing with the naming. First we ask, is it one of the exceptions? No. Then we know that it is ionic, again, because we have a metal present, so it's always going to be ionic. And we know that NO3, in this case, we get a little clue that this is a polyatomic in this fact that there are parentheses present. So we know that we are in our ionic polyatomic ions, but in this case, we have a type 2 metal. Our iron is not one of the ones that we know it can take on different charges. So now we have to do the naming ionic with the thing. So the first thing we're going to do is identify our ions. So we have NO3 from our table. We know that it's NO3-, and we have iron here. And we know that it's going to be 3+ because it has to balance the 3 negative charges from our NO3. Remember, we have one NO3 with a negative charge, and we have 3 of them. We will name the cation. So this time we know that because it's a type 2, we have to do it iron 3. And then we're going to name the anion. And we know that from the table that this is nitrate. We put it all together and we have iron 3 nitrate. I'll let you guys get a little practice doing these guys. Let's see if we can do NH4Cl. CaC2H3O22 and CuNO32. Let's see if you guys can figure these guys out. So the first one is one of our first cases where we used a polyatomic that was in cation. It's pretty much our only cation that we're going to be dealing with, NH4. It's called ammonium. And then we have Cl here, which we're going to call chloride. NH4 has a +1 charge. Chlorine has a -1 charge. This guy right here, if we looked that up in the table, which we would be indicated to do so by these parentheses saying that this is going to be a polyatomic, we'd find that that is acetate. We'd find that it had a -1 charge. And that's going to mesh with what we know about calcium being in 2+, because there's 2 of them here. So we're in our type 1 situation where we know the charge is here. We just call it calcium acetate. In the final one, we had copper, which is one of our type 2 where we do not know its charge. So we have to find it from the context here. We have nitrate, which is -1. We have 2 of them. So that means that our copper had to take on a +2 state. We name it copper 2 nitrate.